Resolution of vector. If three non-collinear vectors are given in a plane, then any one vector may be expressed as a sum of another two vectors. This is done by multiplying another vectors by some real numbers and then adding such that the addition is equal to the first vectors. Consider A vector, B vector and a cap A vector are three non-collinear vectors in a plane as shown in the figure. O and P be the tail and head of the vector A vector. Through O, we draw a straight line parallel to A vector. And through P, a straight line parallel to B vector. Let then intersect at Q. Then we have A vector equals to OP vector equals to OQ vector plus QP vector as shown in this figure. Since OQ is parallel to A vector and QP is parallel to B vector, we can write OQ vector equals to lambda into A vector and QP vector equals to mu into B vector, where lambda and mu are real numbers. Hence, A vector equals to lambda A vector plus mu V vector as shown in the figure. We can find this by the rule of vector addition. Thus, A vector has been resolved into two component vectors lambda A vector and mu V vector along A vector and B vector respectively. Unit vector. It is a vector of unit magnitude and points in a particular direction. It has no dimension and unit. It is used to specify a direction only. That is A vector is equals to mod A vector into A cap, where A cap represent direction or unit vector and mod of A represent magnitude of the A vector. Or it can be written as mod A vector n cap, where n cap is also a unit vector. A vector n cap is a unit vector. Now A cap can be written as A cap equals to A vector by mod A vector. Different types of unit vector. Rectangular unit vector. Here a rectangular coordinate axis is shown. If we have to show the direction along x-axis, then we use I cap vector as a unit vector. Similarly, for y direction we use j cap, and for z direction, that is perpendicular to the plane, we use z k cap unit vector to represent the z direction. And along x dash axis we use minus I cap, y dash axis minus j cap, and z dash axis minus k cap. For example, let A vector is written as, now A vector can be written as A vector equals to mod A vector into A cap equals to mod A vector into I cap, because A vector is along x axis, along x direction. So unit vector, that is A cap, unit vector along x axis we use I cap. So here A cap, in place of A cap we have used I cap. Similarly, another vectors can be shown. Radial and tangential unit vector. This represent radial unit vector ER cap, and tangent to the circle of the circumference of the circle represent tangential unit vector. For unit vector along increasing theta, consider theta is increasing, then we can use a unit vector representing this increasing angle as a theta cap. Now rectangular components of a vector in 2D. Consider a vector OP vector in xy plane. Now it can be resolved uh, into this vector can be shown as a sum of two vectors as shown in the figure. OP vector, we draw a perpendicular from P to on the x-axis at M, then OM vector and MP vector. If we add OM vector and MP vector, this will give OP vector. Now consider OM vector has magnitude AX and MP vector has magnitude AY. Then we can write OP vector equals to OM vector plus MP vector. Now OP vector is equal to A vector, so we have written A vector, and OM vector magnitude into direction, magnitude is AX, and along x-axis unit vector is used I cap, so AX into I cap, and in place of MP vector magnitude is AY and unit vector is J cap, so we are writing AY into J cap. So A vector is written as AX I cap plus AY J cap, equation 1. Now in triangle OMP, cos theta equals to OM by OP. This implies OM equals to OP cos theta. Now OM is equal to AX, so AX equals to A cos theta, and sin theta equals to PM by OP. This implies PM equals to OP sin theta, and OP equals to AY. PM equals to AY, hence AY equals to A sin theta. Equation 3. Using 2 and 3 in equation V1, we get A vector equals to A cos theta I cap plus A sin theta J cap. This is the another form to represent A vector. If AX and AY are given, A vector can be found using equation 1, and if A vector and theta is given, AX and AY can be found using equation 2 and 3. Again, from 3 divided by 2 we get tan theta equals to AY by AX. This implies theta equals to tan inverse AY by AX. Again, a square of equation 2 plus a square of equation 3 gives A square cos square theta plus A square sin square theta equals to AX square plus AY square, or A square into cos square theta plus sin square theta equals to AX square plus AY square. This implies A square equals to AX square plus AY square. Hence A equals to under root AX square plus AY square, where A is the magnitude of A vector. Now in 3D, same same vector or representation can be used in 3-dimensional. Here A vector is represented, if consider A vector is represented by OP vector. Now this can be resolved into 3 components. If we draw a perpendicular from P to the xz plane, then we get at point Q a perpendicular, and consider OP vector makes alpha angle with x-axis, beta angle with y-axis, and gamma angle with z-axis. Now in triangle OQP, this is a right angle triangle, and this angle is right angle. That is, angle OQP is right angle, and OP is the hypotenuse. OP vector equals to OQ. Now we can write according to this triangle, OP vector equals to OQ vector plus QP vector, equation 1, and in triangle OMQ, we can write OM vector plus MQ vector equals to a Q vector, equation 2. Using 2 in 1, we get OP vector equals to OM vector plus MQ vector plus QP vector. So we can write, because OP vector we have chosen a vector, so in place of OP vector we have used a vector. Now OM vector can be written as, because it is along x-axis, so magnitude into direction, and magnitude will be ax, and direction will be I cap. So here ax I cap, similarly mq vector will be az into k cap, and qp vector will be ay into j cap, or a vector equal to x I cap plus ay j cap plus az k cap, equation 3. Now magnitude of a vector is a equals to mode of a vector equal to root under ax square plus ay square plus az square, equation 4. As ax and az are given as ax equal to a cos alpha from given triangle, ay equals to a cos beta and az equals to a cos gamma, equation 5. A position vector r vector can be expressed as r vector equal to xi cap plus yj cap plus z cap, as shown in the figure. Here OP vector represented by r vector. Then this vector can be resolved into three components along x-axis, y-axis and z-axis. That is, this vector can be written as the sum of three vectors, one along x-axis, one along y-axis and one along z-axis, as we shown in the above example. So r vector is xi cap plus yj cap plus z cap, and this is called position vector in 3 dimensions. That is, this is a vector representing a point P in the space, from origin to that point, represents the position vector of that point, and it is represented by r vector. Now from 5, cos alpha equals to ax by a, cos beta equals to ay by a, and cos gamma equals to az by a. Cos alpha, cos beta and cos gamma are called direction cosine of the vector a vector. Now vector addition analytical method, component form. Consider two vectors a vector and b vector in the component form, that is a vector equals to xi cap plus ayj cap and b vector equal to bxi cap plus byj cap. Then the resultant of these two vector, means addition of two vector, is given by r vector equals to a vector plus b vector equals to axi cap plus ayj cap plus bxi cap plus byj cap equals to ax plus bx into I cap plus ay plus by into j cap. Now r vector also can be written as component form. This implies rxi cap plus ryj cap equals to x plus bxi cap plus ay plus byj cap. Equating the coefficient of I and j, we can get Rx equals to x plus bx and Ry equals to ay plus by. Thus each component of the resultant vector R vector is the sum of the corresponding components of A vector and B vector. Similarly in 3D, 3-dimensional, it can be written as A vector axi cap plus ayj cap plus az k cap, and B vector equals to bxi cap plus byj cap plus bz k cap. Hence R vector equals to A vector plus B vector equals to xi cap plus byj cap plus az axi cap plus ayj cap plus az k cap plus bxi cap plus byj cap plus bz k cap, or equals to x plus bx into I cap ay plus by into j cap plus z plus bz into k cap. This implies rx I cap plus ry j cap plus rz k cap equals to x plus bx I cap ay plus by j cap az plus bz k cap. Hence rx equal to x plus bx, ry equals to ay plus by, and rx equals to az bz, where rx, ry and rz are the component along x, y and z direction of resultant vector. For example, if we have a vector equal to xi cap plus ayj cap plus az k cap, b vector equal to bxi cap plus byj cap plus bz k cap, c vector equal to cxi cap plus cyj cap plus cz k cap, find t vector equals to a plus b minus c. We have to find this vector a plus b minus c. So simply we use algebraic operation. We have t vector equal to a plus b minus c. Put all the value of a vector, that is a, b and c. The axi k plus ayj k plus az k plus bxi k plus byj k plus bz k cap minus of cxi k plus cyj k plus cz k cap. Now this can be written as jx plus bx minus cx into I cap plus ay plus by minus cy into j cap plus az plus bz minus cz into k cap. Hence t vector now can be resolved into txi plus tyj plus dz k cap, and equating each coefficient ij, equating the coefficient of ij and k, we get tx equal to x plus bx minus cx, ty equal to ay plus by minus cy, and tz equals to az plus bz minus cz. Angle between two vectors. Here two vector a vector and b vector is given. We join tail to tail two vector or head to head these two vectors. Then the smaller angle is will be called the angle between two vectors. You can take bigger angle also, but it is convenient to take a smaller angle as a angle between vectors. Next, resultant of two vectors in terms of their magnitude and angle theta between them. There are two vectors, a vector and b vector is shown. The angle between them is theta. Now b vector can be represented by ts vector as b vector, because b vector we can draw a parallel line to the b vector, and that will represent same vector if direction is same, because OQ vector and PS vector is equal vector. So if OQ vector is B vector, then PS vector is also B vector. Now OP vector plus PS vector represents OS vector, that is sum of A vector plus B vector is represented by this line, this diagonal OS, which is written as R vector. OP vector and OQ vector represents A vector and B vector respectively. Theta is the angle between them. Now OS vector equals to R vector represents the resultant of these two vectors. Now OS vector equals to OP vector plus PS vector, or OP vector plus OQ vector. This implies R vector equals to A plus B vector. Now in a right angle triangle ONS OS square, this OS square will be equal to ON square plus NS square, and now ON square will be OP plus PN ka whole square. So OS square ON square plus NS square equals to OP plus PN ka whole square plus NS square, or equals to OP square plus PN square plus 2OP into PN plus NS square, equation 1. Now we have OP equals to mod of A equals to A, PS equals to mod of OQ equals to B. This is equation 2. Now in triangle PNS, this triangle PNS, in triangle PNS, cos theta equals to PN by PS, so PN equals to PS cos theta. This implies Pn equals to B cos theta, because PS equals to B. Similarly, sin theta equals to NS by PS. So this implies NS equal to PS sin theta, B sin theta. Thus Pn equals to B cos theta and NS equals to B sin theta. Equation 3. Using 2 in 3, 2, 3 in 1, we get OS square equal to A square plus B square cos square theta plus 2 into A into B cos theta plus B square sin square theta. This implies R square equals to A square plus B square into sin square theta plus cos square theta plus 2ab cos theta equals to a square plus b square plus 2ab cos theta. Hence, r equals to mod of a vector plus b vector equals to under root a square plus b square plus 2ab cos theta. Equation A gives the magnitude of the resultant of two vectors, also known as law of cosines. In triangle OSN, sin alpha is equals to Sn by OS. This implies Sn equal to OS sin alpha equals to R sin alpha, equation 4. And in triangle PSN, sin theta equal to Ns by Ps. This implies Ns equal to P sin theta, or Ns equal to B sin theta. Equation 5. Hence, from 4 and 5, R sin alpha equals to B sin theta, or R by sin theta equals to B by sin alpha. Equation B. And in triangle PMS, sin beta equals to PM by PS. This implies PM equals to PS into sin beta equals to B sin beta. Equation 6. And in triangle OMP, sin alpha equals to PM by OP, or PM equals to OP sin alpha equals to A sin alpha. Equation 7. Hence, from 6 and 7 we have B sin beta equals to A sin alpha. This implies B by sin alpha equals to A by sin beta. Hence, from B and C we can get R by sin theta equals to B by sin alpha equals to A by sin beta. D. This equation is known as law of sines. Again, in triangle ONS, tan alpha equals to Sn by On equals to Sn by OP plus Pn, or this implies tan alpha equals to B sin theta by A plus B cos theta, and alpha equals to tan inverse B sin theta by A plus B cos theta. Also from D, sin alpha equals to B by R into sin theta, and sin beta equals to A by R into sin theta. Equation EFG shows the angle made by resultant vector.